Guys, come on, let's continue. Alex, come on. Okay. Last topic for this morning, we're going to have a look at inequalities. Now, we briefly looked at it earlier this morning with the cubic example, where we had the cubic was more than 0. But we're going to have a look at it in more detail now. And just before we do that, some definitions. I believe you might know these already. So, this here is the, what set is this called? Real numbers, isn't it? All real numbers. Good. This set, what's it called? Oh, no. Wow, okay. Tell me something I don't know. What's it called? Ah, come on, someone must know what this one's called. Integers. Integers. -2, -1, 0, 1, 2. All the positive and negative whole numbers. Yeah? What is this one called? The Q set. What's that called? Yeah, there's a special name for it. They are fractions though. Rational numbers, yeah. They're all the numbers that can be written in the form P over Q, where P and Q are integers, and of course Q is not 0. Okay? Yeah? Now, the last set is a little bit unclear because this set, well, what's it called, this N set? Natural numbers. Now, what numbers are those? Well, with or without 0. So is it this? Or is it like that? No, it's either. See, the problem is it depends on the course and the book. There's not one. Unfortunately, for some reason, I don't know why, there's not one definition. So some courses will use the 0 and some will not use the 0, which is a bit of a pain. So to prevent confusion, what usually happens is if you write N with a little star, you're meaning this one. And if you're writing N with a 0, you're meaning this one. It just prevents confusion. Okay. I'm not sure if I was to guess whoever would write the exam in the future, if they ever use the N, they would use whatever definition is on the A levels in the UK, because it's likely that the person writing the exam would be a UK teacher. Okay? But maybe not. You know, the exam could be written by anyone, anywhere. It is important to know that it depends on the course. Okay? If you want to Google it later, you can check, you know, Google something like natural numbers A levels and see which one it is. Or unless somebody knows off the top of their head which one it is on the A levels. No. Well, you can check it later anyway. But for me, to prevent any confusion, what is normal to see is the use of a 0 or a star then. Okay? Or just to say what the N is at the beginning of the course. Another possibility. Right, let's have a look at some examples now. Can I scroll down? Oh, well, just before I do, just to clear up some further set notation. So, if I was to, well, we kind of saw it earlier. If I was to write something like this, AB, that means all the numbers between A and B, not including A and B. If I was to write it with square brackets like this, that would mean you would include A and B. And you could have one like this and one like this. that would mean A not include, and then B include then. You get the picture here? Yeah. What's this meaning? All real numbers from minus infinity to plus infinity. That would be the same thing as just a set OR, wouldn't it? All real numbers. Yeah. A little bit of vocabulary. You see these brown brackets here? These are called, it's called open sets. And this one here? Closed sets, then, when it's like that. And this one here is open. Just a little bit of terms for you there. Oh, and also, I think we saw this symbol. What's that one called? You remember that from school? Union. Union. So it basically means set A and no, sorry, not or. Set A or B. So if you were to say X belongs to A union B, it's like saying X is in A or it's in B. X could be in A or in B. And then this symbol here, and formally it's called intersection. And its meaning is that X must be in A and B. So whatever A and B are, they must have something in common, some overlap. And that's where X resides. Okay. Oh, and the last symbol, suppose I was to write something like OR with a slash, and maybe I did something like this, -1, 1. What would that set mean? Have you seen this slash before? What does this mean? No? It means all real numbers except for -1 and 1, as an example. So, you know, if you said something like y equals 1 over x, you would have to say x could be any real number except x can't be 0. Yeah? Yeah? That's okay? Oh, and the last symbol, in case you don't know it, what's this symbol mean? Yeah, what's it mean though? Null, what's that mean?
Null set.
Yeah, what's null set? Empty set, yeah, there's no elements, no members. Okay, so that's all the revision of the set notation. The reason I'm revising it is just because sometimes, not always, but maybe 10% of the time, they ask for your answer to be in set form. Anyways, let's have a look at some examples here. Okay, so we'll do, can I scroll down? Yeah. So look, here's an easy enough example just to get started. If they don't tell you anything about the x, you can assume it's a real number. Right, well we know what to do here. We take the 7x to the left, and what do we get? Minus 2x. Yeah? 5x minus 7x, yeah? And then take the 6 to the right, and we get 6. And then you have to be really careful here, because when you divide by a negative, what happens to the inequality? It changes around, doesn't it? So x is less than minus 3. Am I right? Yes. Now, if they ask for the answer in set form, you would give the answer like this. X belongs to the set. Actually, what would you write? Minus infinity, comma,
-3.
and then open or closed here? Open then. Okay? But if they don't specify they want the answer as a set, you can leave the answer like that. Okay, well that's our first example. That's a linear example, but let's look at a harder one now. Okay, can I scroll down?
Yeah.
Yep. Now, this one is an inequality again, but it's a double inequality. So I tell you that minus 4 is less than minus 2x plus 18, less than 12, and x is a natural number which could be 0. There's two ways to do this one. I'll show you both ways. The first way to do this is to treat it all as 1, or well, that's the other way, is to separate it, yeah. So if I treat this as 1, what I'll do is I'll minus 18 on everything. So I have minus 4 minus 18. Minus 18 minus 18, gone. And then 12 minus 18. You see what I did? I applied a minus 18 to everything. So that's minus 22 less than minus 2x less than minus 6. What should I do next? Divide everything by minus 2. So this becomes 11 and this becomes 3 and this becomes x, but they get flipped around because you're dividing by minus 2. So in set notation, what would you say the answer is? X belongs to the set. Open bracket, yeah. 3, 11. 3 to 11. Here we're saying x is smaller than 11 and x is more than 3. This is x smaller than 11 and this one is x is bigger than 3. Yeah? It's okay? But we'll have a look at the other way. You don't have to do it this way. So we can write this example down. As you said, there's the other way is to separate them out into two problems. Oh! No, sorry. That last line is wrong. Well, actually, before I delete it, I'd like someone to tell me why the last line is wrong. I just realised I forgot something about the question. Why is my last line wrong? Why am I not actually finished? Yeah? Looks okay, doesn't it? No, that's fine. No, okay. So look, the reason this is wrong is because my answer is saying x can be any number between 3 and 11, right? So what's the number between 3 and 11? Is 3.5? Yeah, 3.5 is between 3 and 11, isn't it? Am I allowed to use 3.5? No, because at the start I said x is a natural number, so I forgot about that. So tell me, in set notation now, remembering that x is a natural number, what are the values x can be? So they're the natural numbers between 3 and 11. So what are they? 4, 5, 6, 7, 8, 9, 10. That's the answer. It's only the natural numbers between 3 and 11. Not all the numbers between 3 and 11. We'll do another example. Yeah, so be careful with that, otherwise you would have lost the mark. You could test it out. What you could do is pick any random number here, and it should satisfy this. So for example, if I was to pick 4, minus 2 times 4 is minus 8. Minus 8 plus 18 is 10. Is 10 more than minus 4? And is it smaller than 12? Yeah, so these do work. Okay. All right, let's have a look at another example now. Using the other method. Minus 6 less than minus 3x minus 18 less than 12. And let me put this in red so we don't forget. X is an integer. So whenever we get to the answer, we need to carefully pick out the integers only. Okay, so in this method, what we can do is split it into two problems. Minus 6 smaller than minus 3x minus 18. And do I write and or do I write or? Here. No, and. Because you need the whole statement to always be true. So you need minus 6 to be smaller than minus 3x minus 18, and minus 3x minus 18 must be smaller than 12. They both must be true at the same time. Right, we know how to solve this one. What's that? Take that over there. That's 12, isn't it? No? No. Isn't it? Yes. Dividing and flipping, that would be like that, isn't it? And here, this would be 12 plus 18. Isn't that right? 30? And flipping again, this would be minus 10. Now, remember there's an and here. So, we need the integers which are smaller than minus 4. So that means to the left on the number line. And bigger than minus 10. So where am I starting? No. No. Minus 9. Minus 8. Minus 7. Where am I stopping? Minus 5. Yes, there we go. These are all the numbers which are bigger than minus 10 and smaller than minus 4. So this is the set here. So you just to be careful of the last step. Yeah, it's okay. Okay, so they're all linear examples. Let's look at quadratic examples. There are two ways to solve quadratic inequalities. So I'll show you both ways. But yeah, I'll show you both ways. But I think for most of you, there's one of them will be a clear winner for which way you would choose to do it. So let's have a look. So this time x is a real number, okay? No integers or natural numbers. X is a real number. And I want to solve minus 21 x squared plus 58x less than 7 x squared minus x minus 9. Now, I know that looks very messy, but I mean, if we take everything to the right, we can simplify it to begin with. So everything going to the right, what will that be? 28x squared, yeah? Is that right, yeah? Everything moving to the right, yeah? Minus 59x? Minus 9. I'm sure this has solutions. 7x plus 1. Right? Maybe? And then has to be 4x, has to be 4 and 9. 4x minus 9. Although you don't, just to be clear, you don't have to factorize it. You just need the solutions, which you can do using the formula. What I really, really care about, and you can get this using the formula if you want, is really just where the solutions are. There'll be one here at 9 over 4, and then the other one at minus 1 over 7. Okay? This is how you make the answer with the help of a graph. You want, if you look carefully here, you want your quadratic to be more than 0. So, if you start drawing your quadratic, here it's good because it's more than 0. Right? But now this part of the graph is a problem. Why? Well, it's less than 0. And then when we get back here, it's good because we're back into the more than 0. So only the x values here are good for us, and only the x values here are good for us. We can say that x must be less than minus 1 over 7. That corresponds to the first answer here. Or the second answer is x more than 9 over 4. A common mistake that students make is they use more than and more than here, because they're thinking, oh, you know, it's a more than, so the answer is more than and more than. Okay, it's not. X is less than minus 1 over 7, or x is more than 9 over 4, because we want these two parts of the graph. How would I write this in set notation? Bracket. What's first? Minus infinity, comma, minus 1 over 7, close, or well, open. Union. 9 over 4, comma, positive infinity, yeah. So that's given the answer in set notation. Now, I said there are two ways to do it. And I'm only showing you both ways because what usually happens, I found, is I show students one way and then they say, oh, we want to see it the other way, and they say, oh, we like the other way better. And then next year I would show students the other way, and then they say, oh no, we want to see the first way, and then they say it's the first way better. So I'm showing you both ways, and you decide which way is better, I don't care. So that's the first way to do it, and let's have a look at the second way to do it. Okay. Can I scroll down? No. Not yet? Okay. By the way, if this problem was less than 0, if it was a negative, less than 0, what would the answer be? It'd be the red region, yeah, which you would say x must be between minus 1 over 7 and 9 over 4. In between. Yeah. Okay. Let's just write it down at the bottom here. Minus 16x squared minus 73x plus 75 less than or equal to 2x squared minus 8x plus 3. Again, it looks messy at first, but you realize, oh well, let's bring everything to one side and it simplifies. Can I scroll down? Yeah. Okay, let's take everything to the right. 18x squared, yeah? 65? Yeah? Minus 72. Is that right? Yeah? Or if you want to just make it really clear, x squared plus 65x minus 72 needs to be smaller than or equal to 0. That's our problem. Right, so in this method you do have to factorize, whereas in the last method you didn't have to factorize, you could have just used the formula. So we need to get the two factors here. What are they? Thank you. What is it? 9x minus 8, so this one has to be 2x plus 9. Yeah? Okay, so let's have a look at this method. So in this method, you just need to think about what you have. You have two numbers that multiply to be a negative. There's only two ways that that could happen. So you either have this situation, 9x minus 8 is a negative, and 2x plus 9 is a positive. A negative multiply a positive, does that satisfy? It does. Gives me a negative, right? The other possibility is 9x minus 8 is positive and 2x plus 9 is negative. What is the relationship between these two halves? And or? Very good, or. So you have two scenarios, two situations. Either you have a negative multiplying a positive, or a positive multiplying a negative. In both cases, you get the job done. Okay, let's continue on the left. So here you have x is less than or equal to 8 over 9, and x is more than or equal to minus 9 over 2. So, as a set, what would that be? You can picture it on the number line here. X needs to be more than minus 9 over 2, and it has to be less than 8 over 9. So it's all the numbers in between, isn't it? So as a set, if you like, you can write it like this. Oops. Minus 9 over 2, comma, 8 over 9. Yeah? Okay, let's look here. X is more than or equal to 8 over 9. And, what have we got here? X is less than or equal to minus 9 over 2. Let's draw the number line. Minus 9 over 2 and 8 over 9. Now, tell me, on this number line, where do we have the situation where x is more than 8 over 9 and less than minus 9 over 2? In the middle piece?
No.
A, B, or C? A and C. Yeah? No. B and C? No. A? No. A and C, we said no. B? No. A and C, for the third time, no. All of them? No. None of them. None of them. Because, could you say none? Oh, sorry, I didn't hear you. I didn't hear if you said it. Think about it, right? I'm saying to you, give me a number x that is more than 8 over 9 and at the same time is less than minus 9 over 2. Yeah, impossible. You can't do that. Okay? Good man if you got it then. So, in this situation, it's the empty set here. No solutions. Okay? So, at the very end, we got this or this, which really means what do we have as the answer? Just the first one, isn't it?
Yeah.
So, you could do it this way, or you could do it this way. Which way do you think you'll be doing it in the exam? I think so too. Okay. Still though, write this example down as your second way you could possibly do it. Okay, 1, 2, 3, 4, 5, 6 questions there. So, yeah, just for 3 minutes, you can get a start on these.